na sequência, nós vamos falar de um assunto também extremamente importante e está muito em moda, em voga, né? No mundo todo. A gente tem com essa consciência maior, né? Com o meio ambiente, com a questão da reciclagem, né? Com todos os aspectos aí de preservação, né? Do ambiente, do planeta. Então, é um tópico muito importante. Aí, como não poderia deixar de ser, a engenharia de sistemas tem que ter uma participação, não só pelo compromisso da responsabilidade, né? Mas pela questão se a gente faz, né? Sistemas complexos e a gente cuida do ciclo de vida como um todo, né? Desde a concepção, planejamento, aquela coisa até o descarte, né? Normalmente aquele último processo ali, o descarte, né? Ou a retirada ou a aposentadoria, né? Do sistema, ela fica depois, né? Pouca gente realmente às vezes até tem experiência, né? Não foi tanto assim ao longo do tempo. Então, vamos ver como é que a gente pode realmente cuidar desse descarte, né? Do que fazer com o sistema quando ele não for necessário mais, quando ele cumprir a sua missão, sua vida útil. E aí, faz o que com o material, com as informações, com tudo, né? Então, esse é o assunto. E aí eu tenho o privilégio e o grande prazer de apresentar esses dois companheiros aí. Primeiro deles, né, o título, tá, da palestra em inglês é Model-Based Life Cycle Analysis, a SysML Approach to Automating Ecological Assessment in Sustainable Systems Design. E a ideia básica é, veja, desde o design, né, do projeto, da ideia do sistema, já pensar na sustentabilidade, o que a gente vai fazer quando esse sistema, né, não só durante, né, a operação, como é que ele pode ser sustentável, mas principalmente no final, né? E aí a base é análise do ciclo de vida, né, usando o SysML. Então nós vamos ter duas partes. A primeira parte vai ser do Hamza, que ele vai falar sobre a parte conceitual, que já é parte da tese de doutorado, então é Dr. Hamza, né? Hamza Bassam, e ele atualmente ele é instrutor e consultor, né, na oose. E um oose é interessante porque tem um método, né, oose, Object Oriented Systems Engineering, né, que é o nome do método, mas é o nome de uma empresa também, né, oose. E uma das paixões aí do Hamza é promover mudanças positivas por meio de pesquisa e inovação. Vocês vão ver aí uma figura. Ele possui expertise aí na intersecção de engenharia de sistemas baseada em modelos, né, MBSE, e economia circular. Essa é a área dele, né, do PhD dele. E aí, atuando dentro do contexto mais amplo, né, de digitalização e sustentabilidade. O trabalho dele visa integrar práticas sustentáveis com soluções digitais inovadoras, contribuindo para a transformação estratégica de organizações em um cenário cada vez mais orientado aí pela sustentabilidade e tecnologia. E a segunda parte, né, o Axel Scheithauer. Depois vocês me corrigem aí, gente, né? Ele é um instrutor na USE também, né, e nesse grupo aí de MBSI, e também atua no grupo Otto, na Alemanha, né? Os dois estão em Hamburg, na Alemanha. Ele tem como foco a aplicação de metodologias modernas, como MBSI, e integrar a sustentabilidade e a digitalização, visando o objetivo também de auxiliar as empresas a navegar por essa, né, transformação digital, utilizando abordagens avançadas e sustentáveis, de novo, né, casando aí com o tempo, para otimizar processos e resultados, ok? So, agora eu vou voltar para o inglês para dar as boas-vindas para os dois aí. So, welcome Hamza, welcome Axel. I'm sorry, maybe you can correct me on your pronunciation for your surname.
No,
And
that's fine.
the
All
stage
perfect.
yours. Go ahead,
We
man.
understood everything. Thank you very much.
Yes.
Thank you for
Take us there.
introduction. Yeah, hello everyone. Hello the systems engineering community from Brazil. We are happy to have today this presentation for you. And okay, I will share my screen and you can let me know if you can see everything. So, bam, 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 bam.
Yep, all good.
Okay. Okay, now we can go. Yeah, so our presentation is about model-based lifecycle analysis, a SysML V2 approach to automating ecological assessments in sustainable systems design. So here we have a picture of the planet Earth, and it is still green, and we want to keep it green this way. So that's why we have today in our agenda, we will start with an introduction. Who are we? Who is Axel, my colleague, me, and who is our company, oose. Then we will have a background on eco-design or sustainable engineering and model-based systems engineering and how model-based systems engineering can support eco-design. Then we will have a tool demonstration on how can model-based systems engineering make sustainability more accessible to industries. And here my colleague Axel will have a demonstration using the System LV2. And then after that, we will have a conclusion and summary and an outlook. So we start with an introduction. Who are we? I will start with myself. Then I am Hamza Bassam. I'm consultant, trainer, and coach at oose. We deliver open and client-tailored seminars on systems engineering with SysML, including certification and functional architecture for systems engineering, and also MBSE for sustainability. I have my background on aeronautical engineering, where I did my bachelor and master's at in Hamburg University for Applied Sciences, and after that I went into research and I tried to apply more systems engineering or model-based systems engineering for developing sustainable systems, and I started focusing my PhD that I want to pursue also on circular economy. How can model-based systems engineering support circular economy? Yeah, this is to me, and I will pass on to my colleague Axel.
Okay, yeah, I'm holding a master's degree in physics, but it's quite some time ago. In the meantime, I had some 20 years experience in software engineering and project management in various roles. But now the last 15, 16 years, I'm doing coaching and training in the region of model-based methods. So it's systems engineering and software engineering as well. I've written a book about UML, Unified Modeling Language, and I'm in the task forces of the object management group that are dealing with all these kinds of modeling specifications like BPMN, UML, and SysML too as well. Let's continue with our company. Hamza, do you want to say something or shall I?
You can do it.
Well, actually, yeah, this is just a mind map of our company that shows that we think everything needs to work together so that we can really achieve a good outcome in our endeavors. So we need to have systems engineering, of course, that's down below, but we also need software engineering. We need requirements. That's always requirements that we have there. Everything is embedded in business processes. We need to do software architecture, coding, testing, quality assurance, security, all the different things that need to work together. And finally, we need soft skills, especially as systems engineers. And we need to have project management skills. And as a systems engineer, I think especially important, you have to have a good organization where you have lean management, leading on cooperative leadership and so on. So that's our field of expertise, where we do trainings and try to advance the fields. Let's continue.
Thank you very much. So let's have a background on sustainability. So we start with the INCOSE vision for 2035. I don't know if you had the chance to read it, but INCOSE identified 6 mega trends that's going to influence systems engineering through 2035, and sustainability was the first of them. So the question is, what is sustainability? The United Nations define sustainability as meeting the needs of the present without compromising the ability of future generations to meet their own needs. So what does this exactly mean? I want to explain this using the three pillars of sustainability we always have, which is like very well used in a sustainable domain. And in sustainability, we have the economical perspective, the environmental perspective, and the social perspective. So in the economical perspective, we want to have an economic growth. So this is actually what industries have been doing until nowadays. And now with the rise of the climate change, the environment is getting more and more attention, and the social perspective is coming slower. It's still, even in the research domain, it is still very slow. There are less tools and research about it, how to measure it, how to apply it, and everything. And sustainability is about considering all these three perspectives and having a trade-off on about them. So not only focus on the economical perspective, but also the environmental and the social one. So what is sustainable system design? Sustainable system design tries to answer the question, how can we develop systems that meet our customer needs, yield economical profit. So this was always like the focus until now. And so we want to add to it that we want also to promote societal progress and also support the flourishing of the environment. So not only don't we want to preserve it, but we want to bring it to flourish. And that is the question that we are trying to answer. And also, I don't know how is your experience, but I think that we don't know many companies who really have this as a requirement in their products or the system they've developed. So mostly it's only focused on these ones. So that's why we cannot wonder why our systems of today's system, they don't yield a societal environmental benefit. That's why we need to actually rethink the way how we perceive and create value in our company and in our society. So back to our INCOSE vision, the INCOSE said that engineer for sustainability, so to as address this all perspective, it will create a new generation of engineers who routinely assess the societal impacts of engineered systems. So the system that we will be engineering will always be challenged to assess how are they going to impact our society. And for this assessment, there's a framework that is worldwide known. It is defined in the ISO for 14040 and 44. It's called the Life Cycle Assessment Framework. And it defines a standard procedure on how to assess the ecological impact of our systems. It is made of 4 steps. So we start with the goal and scope definition. Then there is an inventory analysis. So you can imagine it's like taking the life cycle of your products and taking every process step of your products and analyzing the inputs and the outputs of your process step. And we need to have an inventory of all these processes, and from the analysis we need to analyze how are these inputs and outputs impacting our environment. So from the inventory we have an impact assessment, and from there we have some interpretation of this impact, and we try to have some direct application, how to improve our products or develop strategies and so on. So this is the life cycle assessments. It is focused on the ecological perspective, but there is also the life cycle costing, for example, for the economical perspective, and the social life cycle assessment for the societal perspective. And they all are based on the same framework. So we see that it's called life cycle assessment. So it's not only about product design or the production. So it's about the complete life cycle. And maybe it's not only about like how the end of life, like how what do we do about our product when we finish with it, like the disposal, but maybe we also want to reuse it again. So this is where circular economy comes in. So we don't want to discard our products. We want to reuse them or remanufacture them or repurpose them and so on. So this is the complexity that we are dealing with. We're not anymore focusing on the system design, but we are more challenged to consider or pushed to consider the complete life cycle. Why do we need model-based systems engineering? Well, there is a high complexity in eco design. As I've said, we have regulation that will be coming on. So these topics are actually, we already are dealing with them, systems engineering, but with sustainability, there will be like more regulations, more stakeholders involved. So we need to manage these requirements. There will be like more functions, more components that are allowing for this new system design. So we need to analyze from cradle to cradle. So from the raw materials that we're gonna extract to produce our system until the end of life of our system, and how we decompose our system, and what do we do with the materials after that. And we need to analyze them, how they impact our system. So we need to have to make uncertain future impacts about a future that we don't know, and how we're gonna impact our world in the future, not only like in short term, but also in long term. And for this, we can use modeling, simulation, and optimization. We will need to integrate different perspectives because, as I've mentioned, that we not only want to perceive like the economical perspective, but also the environmental and social, and there are also other system perspective like performance, reliability, and other parameters. So we need also interdisciplinary integration. So we have different variance and trade-off analysis, which requires also data integration. And there is more and more and more to consider. So how can we deal with all this information? So this is where MBSE come to help us have a grip on this complexity. So we have the complexity from the number of the stakeholders, from the requirements, the different disciplines, the functions and the components. Also, we have different domains that are speaking with each other in different languages. Each domain has their own language, so we need to have a common language that all stakeholders can understand. And we also don't understand our system exactly. So when we develop a system and we want to consider the complete life cycle, or how is our system gonna change, or for example, how the reliability of the system gonna change if we're gonna reuse specific components of our system. So this is like, there is a lack of understanding. And through the modeling and system and simulation in model-based systems engineering, we increase this understanding about our system. So what is model-based systems engineering? So I know we are in the INCOSE, but I want to go briefly on the definition. So model-based systems engineering is the application of the formalized application of modeling to support system requirements, design, analysis, verification, and validation activities from the beginning to in the conceptual design, throughout the development of the system, and also to later lifecycle phases. So here there's also the emphasis that we need to systems engineering or model-based systems engineering is also considered for the complete life cycle, but it is not really used for it. So we want to support this cause and really bring it to the complete life cycle. And the concept of MBSE, and especially which is based on the system modeling language that my colleague is gonna introduce later, is to have a SysML model that's gonna be at the center of our environment, which is linked to the requirements, the document specification, and then we have here the different domains, for example, the mechanical engineering, the electrical, software, and so on. And here we have the different analysis. So we integrate the different domains, and then we can perform different analysis and so on. And the eco design is also going to be one of the domains that can be integrated to our SysML model. And we have seen that we have a very high complexity when considering sustainability. And when should we address it is the question. And the answer is the sooner the better. So we can see on this diagram, it shows the life cycle phases. Here we have the requirements engineering until the development stage. And then here we have the process planning, production uses, and end of life. We can see that that's up to 80% of the characteristic of our system is defined in the design stage. So here we defined 80% of the system characteristic and also how our system is gonna impact our environment or our society. So here we need to put a lot of effort. And not only this, it's also that the costs for design changes are very low at this stage. And we have a high possibility for cost reduction. And here's another figure that shows like the V model. So we have here the left wing of the V where we have the system design, architecture, and so on. And here we have the integration. We can see from the left side that 70% of the defects are introduced on the left side. And only 3.5% of them are found. And here the the nominal cost for defect removal is 1. And then on later stages in the integration, we have very high costs up to 300,000 times. So we need to put a lot of effort, or we should put a lot of effort on this side, because this is where we introduce the defects. This is where it makes sense to find these defects and remove them before we produce our system. So back to the INCOSE vision again. I want to underline especially this point of routinely assess the societal impact. So we have a routine of assessment. So where we see routine, we also see an high need for automation. And this is where we see that MBSE can support us, and especially with the new developed System L V2. So I will pass on to my colleague and to show us how can MBSE can make sustainability more accessible for the industry. Axel?
Yeah, you have to give me the screen.
Yeah. Okay, here you go.
Okay. So we have just learned that it's very important to do life cycle assessment of our systems, and it's becoming more important all the time. And at the same time, we have a lot of models already, and we are proposing to use the models that we already have to also support life cycle analysis with them, and finding even another way to use the model, not just for the engineering purposes, but also for life cycle analysis. And for this, of course, we are using the systems modeling language because it's very well versed to do this kind of analysis. What is the system modeling language? I don't know whether you all know of it. Here is a text from the specification of the System2 specification. It says it's a general purpose modeling language for modeling systems. Yeah, it contains concepts that are used to model systems, their components, and the external environment in the context. So that is the System2. You might have heard about the System1, but now in March next year, the System2 will come out. And it is very exciting because I have been part of the submission team, and I think it is really a big thing that is coming there. And let me tell you why I think it's such a huge step forward. First of all, it does have a mathematical foundation. I think that was a problem in the old System1. There was no mathematical foundation, so everybody could think about this language whatever they wanted. and sometimes it was the same, sometimes it was different. But now we have a mathematical foundation, and we can all agree that mathematics has a very good semantics that is very strictly defined. Actually, this is the basis of this, the line that you're seeing right now, and it's quite understandable even. So it just says that you have specialization relationships between the types in the model, and you can see this, the T that you see here, that was too fast. The T that you see here is the interpretation function, and that means the interpretation of the specific type is a subset of the interpretation of the more general type. I think that's quite easy to understand. That is something that is common knowledge, and this is the foundation of the whole language. Another new thing about the language is that it now has an own meta model. The SysML 1 was based on the unified modeling language, which is over 30 years old now, and it was planned for using for software engineering. It has also had some advantages for using it for systems modeling. A lot of it was already possible with it, but there were more and more limitations that we found when we tried to use it for systems modeling. And now we have a new meta model that is not restricted by all these things of the unified modeling language. Like, for example, at the top of the hierarchy now, we find this meta class type and two subtypes of it, the classifier and the feature. So classifier classifies things, and features are the features of these things. And yeah, that is a very flexible meta model that is now possible for SysML. Next very important thing, I think, is semantic library. You have seen the mathematical foundation is the semantic foundation, but much more flexible is to have the semantics not defined just by mathematics, but by a semantic library. What you see here, for example, is also a very simple thing. You have occurrences. We want to define occurrences in our system, and we want to define that there are time enclosed occurrences, enclosed in the time of the first occurrence. And that is easy to specify what that means, and we are using it in a semantic library as a basis for all the classes and states and actions in the systems language. Then there is the textual notation. Many people have talked about this and think that is a real big deal. I don't think that's such a big deal. It's nice to have this textual notation, and actually we are going to use it for our purposes here, because we need to have some interchange between our lifecycle analysis model and the systems model. And finally, there is the API, the application interface, that allows us to get the information out from a SysML modeling tool and do something with it. Like, for example, analyze the lifecycle with it. Okay, let's try it out. Let's start with a lifecycle model. So first we will need some tool that allows us to do some lifecycle calculations, and the tool of choice here is the OpenLCA tool. We also need some databases, because that is very important. All these data need to be collected somewhere, and that's a big task. As you will see, we have this database really contains a lot of things. And at the same time, we need to model our system. So for modeling the system, I'm going to use the online version here. But first, let's look at the contents of the library here, or the contents of the database for lifecycle analysis. You see, we have flows. These are the elements that are flowing in by constructing our system. I have to move myself over there. And for example, we have, let's say we want to do some energy recycling. We have to select here waste incineration, for example, for plastics. And I'm going to select this here for my system model. You see, there is quite a lot of these flows, and I don't want to have all of them in my model. So what I need to do now is to add a tag here so that we can define or find these elements in our SysML model. So I'm going to use the tag SysML here. And let's do it for the other one as well. I might also need untreated wood in my system model. So I'm going to also add a tag here so that we can synchronize it with our SysML model. And of course, I've done that for others as well. So that we, just to show you how this is done. Now I have to switch over to my systems modeling tool, and I'm going to use the pilot implementation for SysML2. There's a web-based modeling platform that I'm going to use for this purpose. No, first I need to get now the information from the system, from the database into my system model. And for this, we created a small tool, our SysML lifecycle analyzer. First, I need to retrieve the flows from the LCA tool. So I'm going to do that. It will take some time because it needs to scan through all the flows that are in the database and find those that I marked with the SysML tag. So, but as soon as it's done, it should show me the flows that it found. And at the same time, I need to model in SysML. Okay, here it is. You see, these are the flows that are now found in the database, and they are now in a format that I can use in my SysML model. So I'm going to copy this and move it into my SysML model. That was not sufficient. That was not what I wanted. Go back to my model here. What's going on? So I try it again. So copy, I'm going to my systems modeling tool. And now I added all these flows that I have retrieved from the database. They have an external reference to the database, a globally unique identifier, but they are just attributes that I defined in my systems model. Now I'm going to compile this, and I need now to use it in my system model. And I have a very simple system model here, just consisting of two canoes that I want to construct and compare. So one of them is a polyethylene canoe, and another one is a skin-on-frame canoe. And the skin-on-frame canoe, of course, consists of these two parts, a frame and a skin. And now I need to use all these flows that I have imported from the LCA tool. So first I have to import the LCA flows. Then I define that I need some polyethylene for constructing the canoe, 20 kilograms. I need some electricity, and I will have some leftovers, 1 kilogram, that I need to incinerate. And then The same thing I can do for the skin on frame canoe. So here I need some wood, electricity as well, and some wood will also be wasted. And the same for the skin. Skin will be PET fibers, and I also need to incinerate the leftovers. So now I changed this name. I'm going to change it back. I'm compiling it. I think I have to import as well this one. So now I'm compiling it. It has been compiled, and now I'm going to publish it into our repository, SysML repository, where I now can use the API to retrieve the information that is in the repository. And for this, again, I'm going to use my lifecycle analyzer. Somehow it became too large to fit in the screen. One moment. So, okay, now the lifecycle analyzer, I'm now connecting to the repository. Here is the demo that I just recorded, or that I just placed into the repository. I'm going to open it. This will also take some time, but then it will show the contents of this elements. That is not very interesting. This is just the content of the file. What I really need to look at is now the LCA processes that can be generated out of this model. And these are the two canoes with the components that I have defined. So polyethylene and pine wood and electricity and so on. So that is also just for checking that I got everything right. What I now need to do is I need to synchronize it with my LCA tool. And for this purpose, I'm going to bring the LCA tool over here. And synchronize it. So currently we don't see anything because I have to refresh this on this side. But now you see that multiple things have happened. We now have the canoe, the two canoes as flows, because these are the items that are being produced. And then we have processes that do produce these items. Let's first look at the skin on frame canoe. And now we are opening it, and we can see the inputs and outputs that are directly coming from our system model. And for analyzing this now, we need to create we need to find the providers for all these inputs that we have defined here. So I am going to create a product system that allows me to create this information or link this information. There's a nice model graph that I can use for this purpose. So we see here the in and outputs for the skin on frame canoe. We need some electricity, obviously. So where do we get this electricity? We can search for a provider for this electricity. And you see that is the purpose of this model. It contains a lot of different possibilities. Let's just select one of them as a provider for the electricity. Search providers. Okay, here is the provider. Electricity from hydropower. I also want to use the same one here. Okay, so electricity comes from here. For Pinewood, I could do the same thing, but I'm just asking it to complete it automatically. So build supply chain complete, just use the default providers. And of course, there's some chain connected to it. So where's the Pinewood coming from? I can click on the plus sign here, and then I can see some dummy elements here in the database that show me where the what is flowing into the Pinewood. I was a little bit surprised that radioactive tailings are also coming into the Pinewood, but that is what the database gives us. And okay, now we are fine. We have all the inputs here, and we can now calculate this. So let's start the calculation. And the calculation asks me what impact and assessment method do I want to use. You can see that it's another advantage of this database. It contains a lot of impact assessment methods. I'm going to use the first one here, greenhouse gas protocol. And yeah, let's start the calculation. Yeah, and there it is. We have the calculation. Let's look for fossil CO2, and you can see the different contributions of the different things, the different elements that we use. Here, the PET fibers produce 23 kilograms CO2. There's some glass obviously needed for containing elements that we need to produce the inputs. 16 kilograms coming from this container glass. And that is surprising. I would not have expected this, but that is something that we can find out by analyzing. Then, of course, the next step would be to get this information back into our system model. We haven't done that yet. That is some future work that we need to do. But once we have that, we can go into our system model and reason about possibilities to make it more sustainable. So we can have different options. We could now also look at the polyethylene canoe, whether this is better or worse than what we see here. And then we can maybe change the constituents of the canoe and find a better solution. Let's go back to the presentation now. So we have seen, we modeled the system in a SysML modeling tool. We selected an LCA database and marked the flows that we want to use in our system model. We retrieved them and quantified the flows according to our system breakdown structure. And then we synchronized this information back to the LCA tool and analyzed the life cycle. Now we would need to get the synchronized results back and then design for sustainability. So I think, and for the conclusion, I give it back to Hamza.
Yeah, thank you, Axel, very much. Before I continue, Adel, how much time do we have before we get into the Q&A?
Hi, man. Well, actually, maybe 2 minutes. How much?
Okay, I will run like 2 minutes and we'll go like through it very quickly. Yeah, so conclusion, yeah, we can access the LCA database. So this is something that is actually very complicated for and very important for the LCA. So we can create flows. We're using attributes in our SysML model, but all these connections to all where the data is coming from and everything, and the LCA database, it's the most important thing for our analysis. So we also want that the information from our SysML model can be recognized and interpreted from our Open LCA tool for the LCA analysis. Yeah, these stuff are already mentioned by Axel, that we can read from LCA database, create the system and everything, and then perform the analysis. The next steps is that we want to save the results in SysML model and then identify the harmful components there. Outlook, how we go from here. We want to arrive to the INCOSE vision and get to one click to LCA analysis. So we want to create our SysML model, and with one click we want to achieve that we have directly an LCA analysis and also the important results back to our system. So this is a proof of concept. If there is anyone interested in a projects for SysML v2 or LCA, we will be also very open for it, and we would like to test our concepts in real-world systems. And after that, we want to integrate other perspectives like the economical, the social, and other systems perspective like reliability and so on. Yeah, so I will go through this one. So we also want to perform analysis to find the optimal solution between all these different perspectives and all these parameters, and also integrate the circular economy. So we'll skip through this slide. And how do we go from here? You can join us in our webinar in English on January 29th. If you're interested, just get in touch with us and we will send you an invitation link. We also provide trainings on MBSE with V1 or V2, and also variant modeling, safety analysis, and MBSE using LCA. So we also have other trainings on the other requirements engineer, software engineer, and so on. And you can just get in touch with us if you have any interest, if you have any ideas on SysML v2 or the LCA of sustainability and all these topics. We are very open to your contacts. Yeah, thank you for your attention. That was our presentation, and we are looking forward to your questions. Sorry for taking so long time.
Oh man, don't worry. That's fine.
I couldn't stop the SysML v2 demonstration.
That's awesome. Oh, Axel, you are the demo god, because everything that's when you are truly doing for real. So congratulations, man. You did well.
Yeah. So maybe also like a remark to the to the attendees that the SysML v2 demonstration was done using the pilot implementation. So the tools are not very mature enough. So the API is also not mature enough. But this is what the first experimentations and proof of concepts. And we think that SysML v2 is going to be very big, and we're going to be bring lots of opportunities. Yeah.
Definitely.
Thank you very much.
No, man, definitely. That's awesome. Well, I can say how much, how pleased I am to see how your work is progressing. Right? I had the pleasure and the honor to read a little bit from Hamza's thesis, PhD thesis earlier this year. We have been in a partnership, for almost a year now, right? More than a year now.
Yeah.
And
yeah.
Learning with each other, right? So it's a really pleasure to be here with you guys, and the awesome support from Axel, right? The guy just demolishing the demo in there. So from what I remember, from your thesis, from our discussions, what you are doing, now you're putting it to action, right? You're having this prototype. Now it's an in progress work, of course, but it's coming up very nice, man. Because now you can see the charts, the calculations you did theoretically there. It's now just moving across tools, SysML as a venue, as a channel to make this possible, right? as Axel well said, we have now a more tangible, more mathematical foundation for this. So it's I'm really enthusiastic about SysML V2. So thanks for having, showing us this. For us is really awesome. And I'm not sure. We have two questions here in the Q&A.
I already read the questions. They are very broad. I don't think that we can answer them in 5 minutes.
Sorry, man. We are here. We're brothers. No worries. So first one from Bruno Soares. Congratulations on the excellent presentation, Hamza and Axel. Your demo was very interesting and insightful. When considering the life cycle of a system, we often have stakeholders involved at different stages, each with specific expectations. What are the main challenges in creating a model that addresses these stakeholders' expectations, especially when some of these expectations may, well, usually conflict?
Well, I hope that SysML2 will be a big help there, because it is now possible to define views and define renderings for these views that might help different stakeholders to get exactly the rendering that they are expecting. But of course, if they are expecting completely different structure of the model, that will still be a problem. But I hope there is a way forward with SysML2 in this regard.
Excellent.
Yeah, I think also like regarding the stakeholders, I think we, of course, it is best if we can bring the stakeholders together at the beginning so that they meet each other and work with each other. And of course, there will be conflicts. That's why we want to address, have the different perspective and see, performs the variance and the trade-off analysis to find the optimal solutions. We're always going to have conflicts, and we need these the integration between the stakeholders and domains so that we find the best optimal solution.
Especially in this very sensitive subject, right? Because there's the budget, then there is the ecological aspects, the social aspects, so many voices to be heard, right? And try to appease, let's say, right?
Yeah, definitely. I mean, like for industries, of course, we are in an economical market, and industries, companies need to make profit to survive. I mean, not only to survive, but also to thrive and do innovation and everything. And we just need to consider sustainability as another requirement that is important, as much important as the functional requirements also.
Yeah.
So,
cool, man. Thanks.
Yeah.
Next one from Fabio Silva, our president here in INCOSE chapter Brazil. Thanks for your presentation. Sustainability aspects must be more discussed in the SE community. How much gain in efficiency do you estimate having this integration instead of decoupled analysis with MBSE and LCA tools?
I think it's hard to quantify this.
Yeah, I don't know how to quantify it, but where we see, so what we want to do is, or what our approach was, is that for each tool, we use the tool in what they are good for. So the OpenLCA tool, for example, is not very good for modeling, and LCA is a very cumbersome process. So it's difficult to do it in the LCA tool, but it is good for the LCA analysis. It is good at reading the LCA database, and they've given us all this analysis and everything. So we want to use it for that. So the idea is that, for example, a systems engineer cannot have knowledge about sustainability or eco-design and so on. So we will have eco-design engineer working together with the systems engineer. So for example, what Axel showed us with the tag. So an eco-design engineer will look at the OpenLCA tool, tag the flow that are relevant for our systems, and then we'll send them to systems engineer. And the systems engineer will integrate them in the model, and then send again the information about the system to the eco-design engineer. He will then perform the analysis there and then give us back the results. So there will be great integration between the domains. And yeah, I don't know how to quantify it exactly, but we think that we can achieve, there is a high potential for a very seamless integration between the tools. So this is like only for OpenLCA system LV2, and I think also for different other tools that we will have these changes. Yeah.
Anything, Axel?
Yeah.
Okay, so let's move on.
Yeah. I've seen the next question is about whether System L2 could also be used for software engineering. And well, it is probably possible to use System L2 as well for software, but it will have the same problems that we've had in earlier times when we were using UML for systems engineering. So the idea is that SysML2, that the basis of SysML2, which is a kernel modeling language, that this basis will be used also for UML3. Of course, that will take some time, so I don't really know what happens in the meantime. I guess it will be possible to just use SysML2.
I hope so. I'm already doing some experiments anyway, so I do hope so before UML3 reaches, right? Anyway, and I guess this is the last one. André Moutinho, what are the key factors to consider when deciding between adopting SysML v1 or v2 for implementing a model-based systems engineering approach in a project, particularly in terms of learning curve, tool availability, and support for complex systems?
Well, I mean, support for complex systems, definitely use SysML2 for this. Tool availability could happen next year. We already have seen some promising beta versions. So, of course, you never know when the two vendors will really have more than the beta versions available. IBM showed on last week something, so maybe there is some progress there. Learning curve should be lower. I mean, you don't need to know all the details of the language to use it, and it should be easier to understand because it's more tailored to systems engineering.
Definitely. Well, again, we could stay here another time, but it's around midnight for you guys, right? So double appreciation for your time, your attention, staying so late in the night to accommodate to our time zone. So really appreciate Hamza. We will talk later, man. Thanks for coming. Axel, really nice meeting you. Congratulations for your technical work in there, making those crazy ideas from this man here to work. So I'm really excited to see what you guys can come up in the next months or years to come, right? So with that, we thank you very much for your presentation. Really awesome. Hope to see you again next time.
Yeah, thank you very much, and have a nice evening.
Thank you, Adel, for the moderation, for the introduction, and the opportunity to present, and also to the attendees also for the questions and the attention. Thank you very much, and hope to see each other or hear from each other soon. Bye-bye.
Bye.
Good night. Ok, pessoal, voltando aqui no português, acho que precisamos aí de uma boa noite de sono, né, para recuperar de tanta coisa aí, muita informação e coisas novas, né? A gente não está acostumado ainda com todos esses assuntos aí. E ainda vai, né? Estamos ainda no meio da bagunça toda, mas realmente a análise de ciclo de vida é um processo meio ainda um pouco usado, né? Ainda mais quem não é da área dessas áreas assim mais de quem fica muito em software, né? Talvez quase não faça isso, mas quem está nessas áreas aí que tem parte mecânica, parte, né, que atinge mesmo o meio ambiente, vamos dizer assim, precisa pensar muito nisso, né? Aí vem o trabalho deles, né? Então, fica aí a dica, né? Vamos procurar saber mais sobre isso.